Greetings and welcome, internet friends. Mr. Waddy here, talking about two-way tables and probability homework. Here we go. What are we? Algebra 2, 10.3. Here it says complete the two-way table. And this is like a cute little puzzle. I love it. All right. Ooh. Now, this row, question 4, by the way, I only know one piece of information, and so I can't solve those yet. No. But here I've got 2 out of 3 here, so in this column I can figure out that piece of information. I would do the 49 minus 72 and I get 42 right there. And now that gives me enough for this row, and so 56 and 42, I'm looking for the total, the marginal frequency, margin, side, frequent, add them up, and I get 98. 98. So over here, I did have 2 out of 3 already from the get-go, so I could have done, now I'm not adding these. I know the total, I know the no's, and the only other possible outcome was yes, and so 10 minus 7 is 3. And now I can, if I add those, I can get the total down here, the marginal frequency for yeses. So the total number of people that said yes was 59 of them. And if I add across or if I add down, they should give me the same number and I get 108. Okay? Okay. All right. Let's keep scrolling. Here's question 6. And so let's fill it in as we read it. A survey asks 60 teachers. That sounds like the total. Here's the teachers are in a column this time. It could have been arranged the other way. And 48 parents. So the total number of parents right there. I'm tempted to start filling this in, but I'll just keep going with their clues. Are whether school uniforms reduce distractions in escuela. Of those, 49 teachers and 18 parents say uniforms reduce distractions. So they say yes. So that's 49 teachers and 18 parents say yes. Organize the results in a two-way table. Very good. All right. So let's see. Let's go across. What's the total number of teachers and parents that were surveyed? Add them up. I get 108. Now, I could add these across. And we would have, there were 67 total that said yes to the question. To find the number of teachers that said no, well, I know the total, and I know the yeses, so if I do 60 minus 49, I would get 11 teachers that said no. And to find the number of parents that said no, I would do 48 minus 18, and I would get 30. And now, total number of no's. 11 plus 30 is 41. You also could have theoretically found that, and yes, confirmed, if I did the 108 take away the 67, and I would get 41. Now, what's interesting here is, look at this. The teachers, the majority said yes, and of the parents, the majority said no. Of the total overall survey results, total yes is 67 yes, and so it ended up being in favor. But look at this, there were more teachers that voted than there were parents. And so this is kind of interesting. Like, you could speculate, like, well, maybe other people didn't care as much, or only the votes that counted matter, right? Typically it would have been decided this way, and to say more people out of the total said yes. But you could also argue, well, what if you wanted fair voice between both teachers and parents? Would you have calculated a proportional value? It's an interesting concept. I don't know. But anyways, and we've got the marginal frequencies already there. Marginal frequencies were the ones on the side, the totals. And these are the joint frequencies here. They're called joint frequencies because it joins these two labels. So these were the teachers who said yes. So it's and logic between them. Parents and yes, where there were 18. Okay, good. All right, let's keep scrolling. This is how I scroll. All right, use the two-way table to create a two-way table. All right, that shows the joint and marginal relative frequencies. All right, so this is a regular two-way table. This was a joint frequency because it combined male experts, and this was a marginal frequency because it was the total of an entire row, or in this case, the total of an entire column. Now, relative frequencies behave more like probabilities, in which I'm going to figure out essentially what percent of the total, you know, responded that were expert and male or something like that. I don't even know. We don't have any context as to what this was. Who knows? Who knows what it's about? Maybe this is Pokemon experts. You know, they were going to be the very best, the best there ever was. And so here we go. So to calculate probabilities, I need to know the total number of possible outcomes. And so I could figure that out right here. That's the 410. I also could have figured that out by adding up all of these. All right, if I added all of that up, that would be also 410. And so in any of these cells, nope, 410, I'm going to divide by 410. All right. And so if I want a joint relative frequency, I'm going to take the number of successful ways that occurred, right? So the number of male experts was 62, and I'll divide by the total number of outcomes, which was 410. And if I divide those two things, I get 0.151, 15.1%. And so that's why, if I put it as a percent, it feels like a probability, which I could say, the way it would be a probability is if I ask the question, of all 410 people, what's the probability that if I pick one at random that I happen to get a male who is an expert? And then 15.1% would have been the answer to that question. All right, and so for these joint relative frequencies, relative to the total is why it's relative, I'm going to throw the 6 here, and the 24 there, and the 3 there, and 275, and a 40. And yeah, I don't know what this experience is. Could be jobs, could be a hobby, right? Could be whatever. Like I said, could be Pokemon experience. Yep. So if I divide that out, I get about 67%. That's probably, oh no, it might not be exact. If I divide this out, I get 0.098, and so about 10%, 9.8% for that. 0.015. So there's quite a discrepancy between genders here. That can happen with a lot of things. Not necessarily associated to any sort of discrimination. So let's see, here we go. We've got all of these joint relative frequencies is what I just calculated. Now for a joint marginal frequency, you can barely see that word, I just simply can add across. All right, and so yellow, and I would get 0.166. And so what does this joint marginal frequency mean? It means that of the 410 people, 16.6% were experts, whether they were male or female. Okay, add this row across, I get 0.729. So the majority are average, makes sense. And then I've got 10.5% that are novices. All right, and so these are the the marginal, because they're total, they're in the margins, marginal relative frequencies. And if I add this entire column up, guess what? 1. It adds to 1. It's 100% of the people, right? Of the 410 people surveyed, what percent of them were people? 410 over 410. It's 100% of them. Okay. Now, one of the things I'll point out, you although adding is simpler than division, many would regard, you also could have calculated this by doing the 410 divided from the 68. All right, and so if I did this total here divided by, or sorry, this, that's funny, they're both totals. If I took the number of experts and divided by the entire total, I also would have gotten that. So whether you add across or do your division again, they'll work both ways. Add this column, you happen to get, yeah, so 91.9% of the group happen to be male, and here you get only 8.1% happen to be female. All right, and so this sort of thing gives you a lot of analysis. You could also see, does the distribution of experience change a lot compared to whether the individual was male or female, right? You could say, you know, all sorts of stuff. And so we're gonna, in tomorrow's lesson, we'll look at analyzing these tables even further. But I've got one more. In a survey, 49 people received a flu vaccine before the flu season. Received a flu vaccine. So that's the 49 would go here. Okay. Then I've got and 63 people did not receive the vaccine. Okay. All right. And so the 63 is going to go here. Oh, this is going to have us walk through making both two-way tables. So this is a good one. This summarizes all the skills. Great. Of those who received the flu vaccine, 16 people got the flu. So who received the vaccine still got the flu. Stinks to be you. That's the worst. Of those who did not receive the vaccine, 17 got the flu. And you might be like, oh, that's not that different. Weird. Make a two-way table that shows the joint and marginal. Make a two-way table that shows the joint and marginal relative frequencies. So I'm not making relative frequencies yet. This is going to be my relative one. Right now I'm showing the joint frequencies here and the marginal frequencies here. So I'm doing like a half step. I'm figuring out just the plain old frequencies first, and then I'll do relative. Okay? All right. So now let me scroll down. So of these people, if 16 got the flu and there were a total 49, I could subtract those things and get 33 did not get the flu. Here, between 17 and 63, subtract, I get 46. And then for totals, let's find these marginal frequencies. Let's add them across. 33 people got the flu. 33 and 46 is 79 got the flu. And 49 and 63 is 112 got the flu. Okay. So now, in order to figure out the relative frequencies for either the joint or marginal relative frequencies, I'm going to do this kind of like probability, right? And so the total number of people that were in the sample or survey was 112. You could get that 112 by, dealing with those four numbers, or just take the total you already have. And so the denominator for these joint relative frequencies would have been 1112, 112, 112, 112. And then the number of successful ways that could have occurred, although getting the flu does not feel like a success, 16. And so 16 divided there, 17 here, 33 there, and 46 here. Okay. And so I like, one of the reasons why I like looking at these four is, as far as probabilities go, seeing the 16 out of this feels like, it's a geometric region that I'm looking at. It's a part of the whole. You get the idea. And so let's divide those out. And here is 0.143. Here is 0.152. Here is 0.295. And here is 0.41. Wait a minute, what? Okay, 1. Boom, got him. And so we've got this figured out. So, well, no, I won't do any analysis yet. Let's add them up across. So add them across, I get 0.295. So this would mean 29.5% of the people did get the flu. It's too bad. Here I get 0.705. So 70% did not get the flu. If I add those together, I get 100% of the people that were surveyed. And now let's add these columns. 0.438. And here is 0.563. And so add those up. So you can see a majority of the population did not receive the vaccine. Now, that's what's I was kind of interested in is it looks like, and it doesn't actually go that far, does it? Although 15% of the entire group who didn't receive the vaccine did get the flu, and only 14% of those from the total group received the vaccine and had the flu. It looks like, right, you were better off in this case. Although if I compared the 17 out of 63 versus the 16 out of 49, the people who didn't get the vaccine got lucky that year. That was a smaller percentage. But that being said, you know, they didn't reach herd immunity. Usually, well, that's what you wanted. You would have wanted 60% or more having your, you know, getting the vaccine, something like that. And also, as far as flu vaccines go, supposedly, right, every year they try to predict what type of flu is going to be the greater flu that year, and then build the vaccine for it. And sometimes they miscalculate their predictions. And so, anyways, all sorts of interesting stuff and analysis that can take place when you've got two-way tables and you're calculating joint or marginal frequencies or their relative relationship to the total. Anyways, have a great day, everybody. Take care.